Welcome to another mathematics presentation. So right here with me, I've got mathematics paper 1 for 2021. So I want us to go through from question 1 up to question 5. So let's see how we can answer these questions. Alright, so this is our question 1. Question 1 reads, simplify negative 9p minus, in brackets we have p minus 3. So step 1, we are going to copy the question the way it is, which is negative 9p minus, in brackets we have p minus 3. So from here, what you need to do is to open the brackets right here. So how do you open the brackets? There is a negative way. So this negative must multiply all the terms inside the brackets. So we are going to write negative 9p the way it is. Then negative times positive p, you get negative p. Again, negative times negative, you got positive 3. So we have opened the brackets. Then from this stage, what we can do is we have negative 9p minus p. These are like terms. Then plus p. So we need to simplify these like terms. So since there is a negative here and a negative, we maintain the same sign. Then we add 9p plus p. This will give us a 10p. Okay, so plus 3. So this is our answer. We have simplified, or we can write it as 3 minus 10p. So our answer here, we write 3 minus 10p. So I hope you have gotten something. Let us now move on to question 2. Alright, so this is our question 2 right here. Evaluate 9 over, then we have got in brackets the third root of 27 squared. So step 1, we write our question, which is 9 over, then we have the third root of a 27, that is put in brackets and squared. So what we need to do is, first thing, we need to write 9 over, now this third root of 27. Third root of 27 means the number that you can multiply by itself 3 times to get a 27. So this means if you multiply 3 times 3 times 3, okay, so 3 times 3, it's 9. 9 times 3, this will give us a 27. So this tells us that the third root of 27, the number that you can multiply by itself 3 times to get 27, is a what? A 3. So here in the brackets where we have third root of 27, we are just going to write 3 across square because it was squared right here. Then from here, we are going to write, so 3 squared means 3 times 3. So this is 9 over 3 times 3. Okay? So we say 9 over 3 times 3. This will give us 9. So here we can simplify where we just say 9 here 1, 9 here 1. 1 into 1 to give us 1. So the final answer is just a 1. Alright, so we are now come to question 3. Factorize completely 3 over 4p squared minus 27 over 16. So step 1, we are going to rewrite the question, which is 3 over 4p squared minus 27 over 16. So they want us to factorize completely. Okay, that is what they're asking us. So in order for you to factorize this expression completely, you need to look for the common terms, okay, or the highest common factor. So if in terms of the letters, we only have a p right here, okay. Then in terms of the numbers, we have 3 over 4 and 27 over 16. So what you do is, you really need to be careful. So 3 over 4 and 27 over 16. So the highest common factor of 3 over 4 and 27 over 16, we will factor out the same, which is 3 over 4. Open bracket. So when we factor out 3 over 4, when we start dividing, this will give us a 1. We just remain with p squared minus. Now here, what value are you going to remain with? Okay, what value are you going to remain with? So the value that you remain with will be a 9 over a 4. So let me explain what has been done here. So we are dividing this 27 over 16, we divide with 3 over 4. So what we have done is, you have 27 over 16 divided by 3 over 4. So here we said 27 over 16 times. So this will change, okay? Then from division to multiplication, when the operation changes, even this other fraction is affected. The denominator 4 becomes the numerator. The numerator 3 becomes the denominator. So this will give us 4 over a 3. Okay? So from here, we can check in the diagonals. 3 right here, it's a 1. 3 into 27, it's a 9. 4 right here, it's a 1. 4 into 16, it's a 4. So 9 times 1, this is the 9 over 4 times 1. This is the 4. This is the 9 over 4. So it's the one that I wrote here. So what I did, I just said, okay, 3 into 27 and 9, 4 into 16, it's a 4. Okay, so this is how we arrived to this answer. Now from this stage, when you take a look at the brackets, we have the difference of two squares, because we have p squared, then this 9 is a perfect square, also 4 is a perfect square. So we are going to write 3 over 4, open bracket, p squared minus. So this 9 is a perfect square, so the number that you can multiply by itself twice to get 9 is 3 squared, meaning 3 times 3 to give us 9. So I've not changed anything here, it's just the same. Okay, over this 4, it's 2 to the power 2. Okay, because I know when I multiply 2 to the power 2, 2 times 2, 2 times to give me a 4. So from here, we just need to apply the difference of two squares in brackets. You can see we've got square, 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 and then there's a minus here. So we are going to write 3 over 4, open bracket, p minus 3 over 2. We are familiar with this. Then again, open bracket, p plus 3 over 2. So what has happened here is I've just separated what is inside the brackets, because this is a difference of two squares. So I'll get p minus 3 over 2. So I've remained with another p right here. So p again. Now this operation, I've used the minus. In the other brackets, I'll use an addition operation, then 3 over 2. So this is our answer. So here we'll just write 3 over 4, open bracket, p minus 3 over 2, cross, again, p plus 3 over 2. So this is our answer. So you really need to be careful with such questions. Let us now move on to question 4. All right, so this is our question 4 right here. The question reads, the gradient of a line passing through x, 2 and 6, 12 is 2. Find the value of x. So they have given us the gradient of this line that is passing on these 2 points. At that, it's a 2. Okay, so how can we find the value of x? Remember, for this point, they have just given us x, 2. So we don't know the x coordinate, but for this one, it's complete. So in order for you to write, to find the gradient, first, let us write the points that we have. We have x, 2. Okay, then we also have 6, 12. So the formula that we use to find the gradient is m equal to, so we say y2 minus y1 over x2 minus x1. So from these coordinates that we have been given, we just need to rename them. This is our x1 and this is our y1, then this is our x2 and this is our y2, sorry. So what you need to do now is to come up with the data. So the data, we have m, which is the gradient. They have given us that it's a 2. So m is a 2. Then where we have y2, y2 is a 12 right here. Then y1, y1 is a 2 right here. Then where we have x2, our x2, it's a 6. Okay, then where we have x1, our x1, it's the x. Okay, so we just need to substitute these values in our formula. So to substitute, we write m, okay, is equal to, so where there is y2, we are going to put a 12. 12 minus, where there is y1, we are going to put a 2, over, where there is x2, we are going to put a 6, minus, where there is x1, we put the value of x, because we don't have any value presenting the x coordinate. Okay, then from here, where there is this m, we are going to put a 2 right here. So first we say 12 minus 2, this will give us a 10 over 6 minus x. We can't simplify this because 6 and x are unlike terms, equal to, so I've just equated now. Where there is this m, I'll put a 2 because gradient is equal to 2. So this is a fraction, this is not a fraction. We divide by 1. So after dividing by 1, then we need to cross multiply. So this means 2 will multiply 6 minus x. So 2 open bracket 6 minus x equal to 10 times 1. The answer is 10. Then from here, we just need to say 2 times 6. This will give us a 12 minus 2 times x. This is 2x equal to 10. Then we can correct the like terms where 12 and 10 are like terms. So this 12 will go this side. So the 12 will go this side. It's a positive, it becomes a negative. So this side will only remain with what? Negative 2x equal to, so 10 minus a 12. Okay, so negative 2x equal to 10 minus 12. This will give us negative 2. I hope we are moving together. Then from here, we just want to find the value of x. So we need to get rid of the negative 2x right here. So we divide both sides with negative 2, even with negative 2, so that this and this will cancel. Okay, so in this cancels, we are just going to remain with x equal to negative and negative out, 2 into 2, 2 here 1, 2 here 1, 1 into 1, it's 1. So this tells us that the value of x was equal to a 1. Okay, this is x equal to 1. So I have answered this question. I hope it's clear. Okay, we now move on to our last question. So remember, this is just part 1 for this video. I'm going to release another part where we're going to answer questions from 6 up to 10, just like that, until we finish the whole paper. Alright, so this is our question 5. Question 5 reads, shade the region, in brackets we have P intersection Q, union R on the Venn diagram in the answer space. So we have set P, set Q, and set R. So they want us to shade P intersection Q, then union R. This is what they want us to shade. So P intersection Q is this part. Alright, so this is the part that is showing that the elements that are in P and Q are the same. So we have union R. So union R, it means we combine with the elements that are in R. So we shade the entire set like this. Okay, shade the entire set for R. Okay, so this is yes, so this is P intersection Q in brackets union R. So I hope it's clear. I've come to the end of our lesson. Thank you so much, everybody, for having time to view this content. Bye bye.